Okay, guys. Okay, continuation of the question. Question 3. Point 1 says we must consider the following sequence. Consider the following sequence: 5, 12, 21, and 32. Then the question says write down the next term of the sequence. This is a quadratic sequence. So you first find the first difference, which is T2 minus T1. It gave me 7. T3 minus T2 gave me 9. T4 minus T3 gave me 11. You will see that there's no constant difference here. So this is what makes it a quadratic number pattern. So you proceed to find another difference between these three terms here. So it's T2 minus T1, which give me 2. T3 minus T2, which also give me 2. So now we have a constant common difference, which is a second difference. Okay, that's what makes it a quadratic number pattern. Now we need to find the next term. So to find the next term, you take this difference and add it to that difference and add it to the last term there. So it's 2 plus 11, which is 13, plus 32, which gives us what? 45. 45. So 3, 1, the answer is 45. Now we go to 3, 2, and the question says determine the formula for the nth term of this sequence. So we want Tn, good people. So like I taught you in the previous lesson, to find Tn you need A, B, and C. Then you substitute in the place of the quadratic formula. So we say 2a is equals to 2, and then you divide both sides by 2, then you get a is equals to 1. Then you go here, you say 3a plus b equals to this 7. Then you substitute a into that formula, which is 3 times 1 plus b, sorry, equals to 7. Then now b is equals to 4. So that's how you got it. Then the last one will be a plus b plus c is equals to the first term of the quadratic number pattern. So we substitute a 1, b 4, c we don't know, 5 is the first term of the quadratic number pattern. When you add these two numbers, it gives you 5. You are taking 5 to the right. On the left is positive, when it comes to the right it will be negative. So 5 minus 5 will give us what? 0. So it means our a is 1, b is 4, c is 0. Substitute into this quadratic formula, which is Tn is equal to an squared plus bn plus c. Now our a is 1, so if you like you put it here. If you don't like, 1 times any number is the same number. So Tn is equals to n squared plus b is what? 4. You substitute 4 into the formula, then you get 4n plus c, which is 0. So we leave it and then we write only those numbers that we can see. 0 is nothing, so we can throw it away. So that is the formula for the nth term. Thank you very much. Now we move on to question number 4, which says we must prove that a plus ar plus ar to the power 2 plus dot 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 to the nth term is given as a into bracket 1 minus r to the power n or over 1 minus r, but there was a restriction which says r cannot be equals to 1. The reason is if r is 1 it makes the fraction undefined, so r cannot be 1. Okay, so now let's go into our solution. Here they are just simply asking you to prove the sum of the geometric sequence or the sum of the geometric series formula. So here you will be examined on it, and as you can see in the past questions, so take note of it. You write Sn, the first term of every number pattern is called A. Okay, like we have been taught in our various schools that in geometric sequence, the main formula that we use is Tn, let me take you here, equals to ar to the power n minus 1. So if this is the formula, then it means the first term will be a r to the power 1 minus 1, and that'll give you a r to the power 0. What is r to the power 0? Is equals to 1 and dt. So if r to the power 0 is equals to 1, it means 1 times a will give us this a. If you want AR, which means here we will put 2. And then if you say 2 minus 1, it gives you 1. So AR to the power 1 is the same as AR, which is this one that we have here. If you want position number 3, we put 3 here, and then we say 3 minus 1 in this case. If you say 3 minus 1, what do you get? You get R to the power 2, and then we come and put it here, plus dot 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 to the nth term. So in this case, when we come here, our last term of the geometric series, which is Tn, will be written as what? If it's our last term, we write it as the formula for the geometric sequence. What is the formula? Is AR to the power n minus 1. That is our last term. So we call this equation number 1. And then the next thing we'll say, to find the second equation, we are going to multiply the whole of equation 1 by r. So we say let's multiply by r. Okay, so you take Sn and multiply by r, it gives us Rsn, you put it under it. Now on the first position, shift that point, don't multiply it yet. Leave a space there, and then now you multiply A by R, and then it gives you AR, and you put it under the second position like that. Don't write anything for the first position. There's a reason for that, so that you can arrange to cancel. Now the second term, which is AR, you multiply it by R. R times R will give you R squared, so it gives you AR squared. You come and put it under this AR squared. You put your plus, and then you bring the last term again. Then the last term now must be multiplied by R according to this instruction. So when you take it and multiply by R, this is what we get. AR to the power n minus 1 times R. R is the power 1. According to the law of exponents, when you multiply and you have the same base, what do? You add the exponent. So I have my AR to the power n minus 1 plus 1 from this R to the power 1. The minus 1 will cancel that one. Then we are left with AR to the power n, which is written here, AR to the power n, and you can call this equation number 2. So from now we have equation 1n, equation 2. Let's take note of that. We have equation 1n, equation 2. So you subtract now according to the question. We are supposed to find the equation there. So we say subtract equation 2 from equation 1. So now I did it this way. I say Sn, that is from the equation 1, minus Rsn is equals to, now you can see that this AR will cancel the AR because we are subtracting. Then the AR squared will cancel the AR squared, we are subtracting. The last term will cancel the last term, we are subtracting, and here we'll be left with AR to the power n. So now you will see I have Sn minus Rsn, then it will be now A minus what is left here, AR to the power n, like you can see here. Then now you take a common factor on the left, which is Sn. You can see Sn in this term and Sn there. So when I bring Sn out, I'm left with 1 minus R on the left hand side. And then here too on the right hand side, I take a common factor, which is A. So when I take A out, I'm left with 1 minus R to the power n. You can see most, right? So let's focus. I'm left with 1 minus R to the power n. Now the formula says I must get the denominator to be 1 minus R. So I go to the left hand side, it's multiplication. I have the right to divide both sides by 1 minus R, and here also by 1 minus R. This will cancel the bracket here. Therefore, what is left? Sn is equals to A into bracket 1 minus R to the power n, or over 1 minus R, where we say R cannot be equals to 1. So that is how we prove this formula. They can also ask you to prove the other one, where you have to say A into bracket R to the power n minus 1 divided by R minus 1. In that case, you will subtract equation 1 from equation 2, and then it will lead you here. Thank you.